The curved space-time continuum, a fundamental concept in Einstein's theory of relativity, echoes this ancient wisdom. The curvature of space and time around massive objects like stars and galaxies isn't just theoretical, it's observable. The warping of light around massive objects, known as gravitational lensing, is a testament to the universe's curved nature. Furthermore, Howard's insights find parallels in the realm of quantum physics. The elusive nature of elementary particles, their existence in probabilities rather than definite positions, aligns with the idea of a universe beyond straight lines and predictable paths. This is where Howard's theory about finding something in the void becomes particularly intriguing. The void, often thought of as empty space, could be teeming with these fundamental particles, invisible threads weaving the fabric of the universe. The flower of life, therefore, is not just an ancient symbol, but a representation of the universe's deepest secrets. The 6,000-year-old secret isn't just about a geometric pattern, it's about the very nature of reality itself. It's a symbol that has transcended millennia, bridging the gap between ancient wisdom and modern scientific understanding.
I've spent 45 years searching these things out and trying to figure out what the universe really, how it really worked. And we've come to find that the universe, they are abandoning the standard model, the ideas of black holes and dark matter, for an electric model of the universe. There's tons of paperwork of Da Vinci working on the flower of life and trying to unravel it. But every single existence, every single example, you see him making straight lines and trying to make these straight lines bend in, and therefore he was never able to open it up. Because all the universe is curved, all space is curved. And as a result, what I was doing in trying to find these straight lines, I abandoned the idea of the straight line. The shortest distance between 2 points is curved space, because you cannot force your way straight through space. Even electricity, as it moves from a southern plane to a northern plane, it always goes northeast in its direction. And magnetism, as it expands out, it goes southwesterly. And that's the spin. That's how you always know whether it's magnetism or electricity. It's the spin. Is it northeast or is it southwest? But in trying to define the spaces, it allowed me to see that all of these in between, what we have been dealing with is these petals. All of mankind have dealt with these petals, but it's these other shapes that we've ignored constantly. Well, those other shapes were the in-between spaces. They were the things that filled up the vacuum of space. And all these particles that I have, I think are the full proof of that. And it is also the full proof of the wave particle argument.
Building on Terrence Howard's profound insights about energy and motion, we embark on a journey to unravel the universe's hidden language, a language articulated not in straight lines, but in dynamic patterns and ceaseless movement. This exploration leads us into the realms of modern physics, where the concepts of energy and motion are understood not as linear trajectories, but as complex interplay of forces and fields. In the heart of this exploration lies the fundamental principle that all energy in the universe is in perpetual motion. This motion manifests in vortices, waves, and spirals rather than straight lines. Modern physics, with its study of galaxies and celestial bodies, supports this view. Galaxies do not arrange themselves in straight paths, but in swirling spirals and elliptical orbits, a pattern mimicked in the structure of the DNA helix and the spiraling arms of hurricanes. Howard's perspective resonates deeply with this view, suggesting a universal pattern of motion and energy that is curved and cyclic. The wave-particle duality in quantum mechanics, a concept that posits particles as both discrete entities and probabilistic waves, further illustrates this departure from straight-line thinking. This duality challenges our conventional understanding of motion and trajectory, proposing that at the fundamental level, the universe expresses itself in probabilities and patterns that defy straightforward categorization. Moving from the macrocosmic to the microcosmic, we delve into nature's curves, seeking the essence of the universe. This chapter explores how the natural world embodies the curved, non-linear geometry that Howard emphasizes. From the majestic sweep of rivers to the delicate curl of a fern's frond, nature abounds with curves and spirals. These patterns are not arbitrary, but follow mathematical principles such as fractal geometry and the Fibonacci sequence. Fractal geometry, with its self-repeating patterns, offers a window into the infinite complexity of nature. These fractals are evident in the branching of trees, the structure of snowflakes, and the rugged contours of mountain ranges. The Fibonacci sequence, another mathematical pattern, manifests in the arrangement of seeds in a sunflower, the spirals of a snail's shell, and the proportions of the human body. These patterns reveal a hidden order in nature, an order that transcends the straight lines of Euclidean geometry. Howard's perspective on the absence of straight lines in nature aligns with these observations. By recognizing the curved and recursive patterns that govern the natural world, we gain insight into the essence of the universe. These patterns are not mere coincidences, but are reflective of deeper, universal principles that govern the growth, structure, and movement of everything in the cosmos. As we delve deeper into this exploration, we prepare to encounter a concept that further challenges our conventional understanding of mathematics and its application to the physical world. Terrence Howard, in his insightful speech, introduces us to a fascinating aspect of this hidden order: the concept of mathematical loops. This intriguing idea, exemplified by the looping behavior of the square root of 2, reveals an unexpected and seemingly paradoxical nature of mathematical operations.
But all of these wave conjugations, all of these states of matter, all of these things, it's time for that to be changed now. We have changed all of our buildings to be aerodynamic. Our airplanes are no longer based on a two-dimensional Euclidean way of life. But our math is still based on a two-dimensional way.